Hello everyone. Can everyone hear me? Atlanta, Georgia. That's great. If you can hear me, you can write something in the chat. That's great. Let me. All right. Where are we? All right. Great. Hmm. All right. Good to see everyone joining in. That's great. Yeah, I am in Houston, Texas. It's extremely hot. You can't really go outside. I mean, from 8 a.m. in the morning till 8 p.m. at night, you cannot step outside. It's so hot out here. It's like, I think in terms of Fahrenheit, it should be 110, 115 with high humidity. So, just started learning this today in my class. We're not using any of this. Will it be helpful? Hopefully, it will be helpful. Yeah, we're going to be using SwiftUI, so hopefully it will be helpful. Yeah. All right, let me go ahead and plug in my phone and charge my phone because most of my chargers are not working. Hold on a second. Atlanta, Georgia. Okay, good. 43, 43.33 Celsius. That is, let's see, 43 Celsius. Yeah, so about that's the same. That's 43 Celsius is our temperature over here in Houston. We are not using Swift UI. Well, you will eventually. So it's a good thing to start learning. All right. And this will be kind of like a part one because I don't think we'll be able to cover all the things. But at least we'll be able to get started with Swift UI and populating table view, maybe even navigating to the categories and all that stuff. So hopefully we'll be able to do all of that stuff. All right. All right, let's go ahead and get started, everyone. Thanks for coming. Okay, so what we are trying to do in this session, and if you have any question, go ahead and write it down on the chat, and I will be able to answer it. All right. So what we're trying to do in this session is just to get started. We will try to display all the categories into our display in our SwiftUI iPhone application. And then if we have time, we can also navigate from one screen to the other. We are using this API. It's a fake store API, so all the data is fake, but it's a JSON data. So you can definitely check it out. If you want to just play around with it, create an app, then this is a great API to just play around with. All right. You can see that there are a number of different URLs that they provide. And if I go to this URL, like getting all the categories, so it's a shopping store, I guess, of sort. And you can see that if I go to categories, it's just going to give me this kind of a result. The categories are clothes, electronics, furniture, shoes, and others, I guess. So our first task is to display all these things in our SwiftUI. All right. Now, there are some things that I've already implemented. All right. And I'll give you the code, or you can just find that stuff in your application. Some of the code I have already implemented, but maybe we will go and implement it again. All right. So some parts of it we will kind of like implement it again, maybe. But taking a look at this application, you can see that this application is called like a simple store app. I have a one only view over here, which is called category list view. And currently it doesn't really display anything. And let me go ahead and increase the size so that you can see. This should be hopefully big enough. That's actually pretty big. So it should be big enough for you to see. All right. Okay, let me just wait for the Xcode previews to load. Sometime it can take a while to load, but that's what we're trying to do. Now, one thing to mention over here is that I've already written the networking layer. That's a lot of code. I'll give you the code, but that's, you don't really, I mean, there are so many different ways of, writing the networking layer. So, I didn't really want to write it again and again. It's just too much work. So what we want to do is we have a category list screen, and we are going to display something. So which architecture are we going to use? Now, I try to use an architecture, I call it personally MV architecture, not MVVM. But if you are doing MVVM, that's perfectly fine. I think when I show you the architecture, you might say, oh, hold on a second, this is exactly what I do also. So you'll see what architecture it is. You can name it anything you want, but this is something that I use. All right. But you can use any architecture you want. I'll show you how I do things. If you like it, you can use the similar things. All right. So I've already implemented the HTTP client. That's a lot of code, but the HTTP client is more of a generic client, kind of like a web service that's going to just go ahead and make the request and give me the result. I can show you the code, but it's a lot of code. All right. So it's more of a generic thing. So don't worry about this part. We will simply be using this part and getting the result from the URL. Okay. All right. Because if I try to implement this live, it's going to take forever. That's a lot of code, right? So let's just say that we already have the HTTP client, meaning we already have something that can go to the something that can go to the API, this one or any API, and get the result. All right. Can we go over that code? Well, yeah, we can take a look at this code. So it starts from over here, HTTP client, and it has a load function. That's the only function it has. You're going to pass in the resource. Resource simply means that whatever you're trying to get, this is a resource. Resource should contain a URL and a method, get or post or put or delete, and type of the model that you're trying to retrieve. Then I go through a couple of different switch cases, set up the component, set up everything, and eventually I make the call somewhere around here, I think, and I get the result and I return the result. That's it. All right. So you can find this implementation a lot of different places. This is more of a, I call it kind of like a generic HTTP client or a generic HTTP service that can get the data. It doesn't hold on to the data, so it's stateless, and it just gives you the data, and that's it. All right. So that's what the HTTP client is actually doing. So now the question is, let's go to the category list screen. If I want to display a list of categories which are over here coming from the API, coming from the fake store API, how would I do it? So I'll show you a couple of different ways how you can accomplish that. All right. Category list screen is also our home screen, kind of like the first view that the person sees. So what we want to do over here is kind of like display a list of all the categories. That's what we want to do. But the first step is always, well, how do we get the categories? So let's go ahead and see. The first thing I would do is I will simply create an instance of the HTTP client, or kind of like this. Eventually, you can create, and you should probably create the HTTP client protocol so that you can mock it also, because this particular API is unmanaged, meaning I don't own it and it can change. So should be a good idea to create a mock HTTP client also. But let's just not do that complexity for now. HTTP client. So basically the category list screen has a dependency on HTTP client. Now keep in mind, this is the one way that I am showing you, and I will show you a very different way also. But let's just talk about a very simple way to accomplish this. If I try to build this, it's not going to like it, because in my store app file, I'm also using category list screen and I'm not passing anything to it. So let's go ahead and pass it, make it happy. Again, in your application, you can create a HTTP client protocol so you can mock it. We're not going to mock it right now. We don't have time. Maybe in the future we can do it. That's a correct approach, but I'm just showing you how to get the data displayed on the screen for now. All right. And also keeping in mind that this category list screen is the only screen where we will display the categories. There is no other screen in our application where we will show a list of categories. So now the question becomes, well, how do we get the categories? Let me go ahead and put like a placeholder over here. You don't really have to create a placeholder, but I like to sometimes create these placeholders so that I have an idea of what I'm doing. So eventually all the categories will be displayed over here. Let's say category 1 or something, kind of like this. Eventually, obviously it will not be category 1, 2, and 3. It will be category coming from the server, coming from over here, from the JSON URL. So how do we do it? Well, I can go ahead and create a function over here right inside the view. Load categories. Most people over here are already software developer in the learning process. I think most people over here are from different backgrounds. So this is definitely not an introduction to SwiftUI, but this is more of a just showing you one way or several ways of consuming data from a JSON API. All right. So I create this function load categories. Inside over here, I will create a resource. The resource simply says that what am I trying to get? APIs dot categories dot URL. This is a URL for the category, and I'm going to get category dot self, meaning an array of categories. Next, I will use this by calling in the resource, by calling in the load function and passing in the resource. This is going to return me, as you can see, well, it doesn't show up over here, but it will return me some sort of array, some sort of a list or something. I don't know why it's not liking this. Let's go ahead and build this. What am I missing over here? Category, don't we have a category? Oh, we don't even have the category model, so totally forgot to do that. Let's go ahead and create the category model, the thing that we actually need to get. We didn't even create that, so it's not even going to work. So what does the category model look like? Well, it should be pretty simple. We have to map the information that we have over here. So what does the category model should contain, right? We should contain the ID, we should contain the name, we should contain image and all that stuff. So it will be similar to this one. We have a category that is codable, identifiable, and hashable, which we will see later on why. And we have ID, name, and image, which maps to ID, name, and image. Okay, great. Let's go back to our code and build it. Okay, so http.load function is a async function, so we have to use try await over here. And http.load function is going to return you an array of categories. Whatever we are telling it, it's going to return it. So where should we put it? We can create a state over here. You can call it categories, a local state. Category, we will assign it nothing, and we will get the categories. Simple, that's it. But we're using a try over here, so we have to use again the do catch and all that stuff. So let's go ahead and put it in the do catch. Right? Keeping in mind that the categories that we are retrieving over here will only be used in our category list screen. This is the only view where we will be using categories. Once we have the categories, we can go ahead and replace this part and thus iterate through the categories. Remove that part. We will get the category. And if we want to display something, we will say category dot name. And let's see if it actually builds. Oh, so what am I missing? Well, we forgot to call the load function. Load categories. There we go. There we go. Nice and simple. We didn't really have to type that much code to get all the categories from the JSON API, and this is all the code we had to type to basically display all the categories. Any question regarding this? This is just the one way. I mean, there are some other ways that I will discuss later, but this is just one of the ways, at least that sometime I do this way if I know that categories will only be used in the category list screen, which in this case, they are actually going to be used in one screen only. So I don't really have to manage the state of the categories beyond the view itself. That's why this particular categories is kind of like a local state, private state, which is for category list screen. And once the category list screen goes away, the categories array also goes away, because nobody else is using that. So this is just one of the ways you can do that. Any question regarding this approach? This approach is very dependent on the things that you're trying to do with the categories. So we are just trying to get the categories, we're just trying to display the categories, and that's it. Now, if I want to sort the categories because of their IDs or something, I can actually write a sort function right here, and I can do that also. So I can create, let's say, property called sort categories or sorted categories, which is going to return an array of category. And I can do something over here so that I get the sorted categories, like categories dot sorted. Again, we have to make sure that we understand that the categories are only used in this particular instance. All right. So now I can go ahead and say guard let ID, left-hand side ID, which is left-hand side dot ID. And this is like if you're sorting your categories, right-hand side ID equals to right-hand side dot ID, I think. Else, oops, we will return false probably. And somewhere along the line, we can actually say left-hand side ID greater than right-hand side ID. So basically it will be sorted by the ID itself. What am I missing over here? Return maybe? And once I have the sorted categories, I can probably pass it over here and sort all the stuff. And there we go. It's actually sorted. If you noticed, now it's actually sorted in a different way. All right. Questions? If you have a question, you can type it up in the chat, and I can definitely answer those questions. Again, keeping in mind that this is just one way you can fetch the stuff and display it on the component, on the view, if that component or that view is the only one using those models, array of categories or whatever. So, and in this case, actually it is. This is the only view in our application that will be displaying a list of categories. So all the stuff I'm typing is I'm just typing inside the view itself, which is a view model, and we are simply populating it. We're doing everything we can. All right. For this part, I think the question mostly people ask is, how do I test this, right? How do I test sorted categories? The way that you test it is through the use of Xcode previews. It's not really a complicated thing to test. I mean, there's not much of a logic in there. There is some logic, don't get me wrong, but it's not much of a logic. If you had a filter operation which contains a lot of logic, then you can extract and struct out of it, and then you can test it out. But right now, it's not much logic, and we can accomplish all of this by using just Xcode previews. Actually, in one of Apple's implementation at WWDC, they were also saying the same thing, that your previews are kind of like a test. If I see the preview, simple previews at least, like this one is fine, then I can be sure that it is working correctly. All right. So this is a very simple way where the category list screen is the only one who is using the list of categories. Sometime you want to add a category, delete a category, and other views may need a categories, like a list of categories or something. So how do we accomplish that part? So now I'm going to change the implementation over here to something different. All right, so we're going to go back to kind of like where we started, and we're going to redo the whole thing, but with a different structure. So what I'm going to do is I will remove this dependency from here. I will just remove everything. And I'll go back to the previous, completely like when we kind of like got started, like hello world. So I'll remove everything over here, no dependency, no nothing. We'll kind of go back to the hello world kind of example. Okay, so we're back to where we started. And in this way, we are saying that, okay, how can we do it in a different way? Maybe somebody needs to keep track of the categories, so how can we do that? One way of doing that is to create a data store or something that can keep track of the entire application, like the state of entire application. You can call it data store. I like to call it store model. You can call it anything you want. All right, so let me go ahead and create that. I'll create something called store model. This will be an observer. If you want to call it a view model, that is fine. I don't really like to use the word view model because the view model kind of dictates that, oh, this is going to be functioning on a particular screen. Category list screen will have a category list view model. Add category screen will have add category view model. But this is not that kind of a thing. It's going to be for everyone. Every screen in my application is going to get the data through the store model. So what properties do we need in there? Well, we need a publish property. which is categories. So this store model is going to do the same thing we were doing, but now this is the extra layer that we are adding so that other people, if they want to get access to the categories, they can using this approach. And I'll say load categories. So all those function goes over here. All right. And this will have a dependency on HTTP client. So you need to pass an HTTP client. It may look like a view model, but I'll show you that it's not. It may look like a very close to view model, but it's not. All right. Async throws. Okay, so what should we do over here? Well, over here we can ask help from HTTP client dot load resource. Well, let's go ahead and create the resource. Resource simply means that what are you trying to get? So resource will be APIs dot categories dot URL. The model type that we are using is category dot self, and we can pass in the resource. Try await. We get something back over here, but try await. It's going to give us what? Categories. So we'll just assign to categories. There we go. I think that should be more than enough. So now we need to be accessing the categories, or we need to be getting the data through the use of store model. And if you want your store model, now store model, you can call it data store. You can call it global model, global something, whatever, because this is the only observable object I will create in my entire application, unless the source of truth has changed. But right now, the source of truth is the server. So I'm not going to change it right now. It doesn't really need to be changed. I don't really need to be creating separate view models for every single screen that I add. I will create a view model or something similar if the source of truth has changed, meaning maybe I'm reading the data from a location manager, and that's a source of truth. Absolutely, I will create a new observable object, but I will not create an observable object just because I've added 30 different screens. And that's a very important point to note over here. All right. So how do we access store model? Well, if you want store model to be available to the entire application, because the store model is carrying the state or maintaining the state of the whole application, then you should inject it in the environment. So I'll inject it. I think I have to inject it. Yeah, I'll just inject it over here for now. There we go. Store model. That's it. Now every single, oh, and we have to pass an HTTP client because that is a dependency. Now store model will be available to everyone in the app. How do we use it? Well, let's go to the category list screen. In our previews, we will also inject that so that our previews can work. Now I know most of you are thinking, didn't he just change the name of a view model to the store model and calling it the store model, but it's a view model? No. All right. The answer is no. Why? Because I didn't add a couple of different things actually. The first thing, and the most important part to learn over here, is that I'm not going to be adding another observable object just because I'm adding another screen. And that is the part that can be dangerous, because that means that every single time you'll be adding a new screen, you will be adding a new view model, which means that if you have 10 screens, you have 10 view models. That will be very hard to manage, right? The other thing is that if I have any presentation logic, I can just add that presentation logic in my view itself. That's perfectly fine, like the sorting that we did. That is fine, okay? Now let's go ahead and see how we can use it. I'm going to use the environment object and get access to the store model. I'll simply call it model. There we go. So we're doing the same exact thing. We didn't really change anything, but now we have a layer in between. And the reason that we have a layer in between is because we found out that there will be some views somewhere that will add a new category, that will delete a category. Maybe some other views will need that category. And that's why we are now taking help from environment object so that it will be available to everyone. and I'll call over here load categories. Now we don't have load categories. I like to create these small functions like load categories, like a helper functions. So I'm just going to create over here load categories, categories. And over here, we're going to take help from the model, right? So model dot load categories. And still pretty simple code. I mean, I don't think it's complicated at all. Now it's going through the model itself. Is it not? Load categories is not async? It is async. What is he talking about? Oh, this is not async. Okay, there we go. So this is another way to write the same thing that we did before. The only difference with this is now store model is kind of like keeping track of the entire state of your application. What does that look like in the future? Let resource equals to resource. Is this a HTTP class? So resource is a defined over here, a simple struct that is based on the URL that you provide, a method which is get or post, and a model type that you want, that you're requesting, that this is a resource type we are requesting. All the URLs are coming from the API.swift, which is simple enum, and you can see I kind of like hard-coded everything over here. All right. So eventually what's going to happen to this store model is that it will have some more functions. Load products by category ID or something. You're going to pass in the category ID. I mean, we don't really have it right now, but I'm just telling you that this is going to happen in the future. And we will have another published property, which will be products. So basically the entire state of the application will be maintained by store model. So what does product looks like? Well, I can just go ahead and create a product model and we can see how it looks like. So I'll create a new model. I'll call it product. And this is what the product will look like. All right. And we can take a look at the product. It's not a big deal. Product should be over here. Products. There we go. These are all the products. Based on some, well, these are all the products. They're not really based on any category. These are just all the products. There are some URLs that we can use to get the products by category. I think if I type in category/1/products, maybe that will give us something. There we go. So based on the URL, now we are getting all the products based on that URL. All right, so that's just the URL itself. So let's go back over here. So what this does to our application is that we have one point, one class that is responsible for maintaining the state of the entire application. This is a good solution for small or even a medium-sized projects. But if your project is like super huge, then you have to think of creating multiple observable objects, which can be based on the type of features that they provide. One example can be maybe you will have an observable object called catalog. So if you want anything from an e-commerce application related to the catalog, that can be item, that can be catalog item, catalog category or something, then that is going to manage it. If you have fulfillment, then you will have over here fulfillment. All right. If you have inventory, maybe that will be 3. But the thing that you must understand over here is that I'm not creating these observable objects based on the new screens that I'm adding. I'm adding these observable objects because either something has changed, meaning either the source of truth has changed, or I'm adding these things because the feature that I'm trying to get is a little bit different. So I need to break down the store model, or else the store model can be very, very large for large application. For medium-sized application, for small application, you will get away with just one store model. Again, one other thing that I want to point out over here is that this kind of a pattern I only use for client server application. If I'm building a Swift data or core data application, I will be using something different. All right. So this is what it looks like right now. So let's go ahead and go to the category list screen first and see what it displays. So it should be able to display all the categories. Great. If we want to display, let's say, an image of the category, we can go ahead and wrap this up in an H stack, and we can use an async image. And I think one of them placeholder, so we can pass in the category.image URL. We'll get the image. We can say image is resizable, and aspect ratio fit. I don't know if we have to provide aspect ratio over here, if I'm just going to size it up anyways. Width can be 100, height can be 100. Placeholder means that what kind of an image you want to display if nothing gets displayed. I don't really have any image to display, but make sure that you use some good image over here. So there we go. We got the image to be displayed also. All right. Pretty cool, right? I wonder if we can actually clip this image, or you can make it round and all that stuff if you want to. That's fine. Let's see what other things do we have for the categories. I think that was pretty much it for the categories. Image and ID and the name. All right. Now the question is, well, okay, how can I make sure, or first question is actually, can we improve this? Is there any refactoring we can do? We have created this feature, but is there any refactoring we can do to make it better? And one thing that I like to do is to divide my view into sub-views. So all of this thing inside the edge stack, this can be created into a separate view. So let's go ahead and do that. I'm going to go into my new group. I'll create a group called views. And in the views, I'll create another SwiftUI view, and I'll call it category view. And I'll go back and copy the H stack, the whole H stack, and paste it right here in the body. Now this H stack or this thing depends on the category, so we need to pass in the category. There we go. And now this is going to complain. It's like, I mean, hey, you need to pass in a category. So just so that our previews are not dying on us, we can go ahead and do that. And I need some sort of a dummy image. So let's go ahead and find an image. I'll go back. Actually, we should be able to find something. Sometimes these images don't really work, but let's see. We can say URL. And this, just so that our view can at least compile correctly. So now what we have done is that we have taken that H stack and put it into a separate view so that we can easily use it in other places also. Category view, passing in the category. The result is kind of like the same. You can see that it still works, right? Now let's go ahead and see that how we can implement navigation, which means that if I click on this category, clothes, then I should be taken to a product screen. For that, in the previews at least, I need to wrap this everything up just for the preview's sake with a navigation stack. And once we wrap it with a navigation stack, now I can set the title. We will simply call it categories, so I can see the title. We have the categories title over here. Great. And now I can finally create some sort of a navigation. So we can use a navigation link. And there are many different ways you can create a navigation link. The value of the navigation link has to be hashable. So that's why the category struct is hashable. And this value will be passed to the navigation destination. So I'm using, I think it was iOS something, 16 or something, where they introduced navigation stack and all that stuff, so I'm using that. So now you can already start seeing, not sure what happened over here. No. Okay, so now I can already start, let me see over here. I think I pressed the wrong button. And now this mark is there always. There's no way to get rid of it. Anyway, I don't think that's going to mess up our. Okay, here we go. So all of the stuff, all of the arrows are still there, you can see. So now what we want to do is we want to go to a separate screen, a product list screen. Whenever we select a category or clothes, we want to go there. And for that, you will need to implement the navigation destination. And let's see where we can put this stuff. Usually I put it like at the end, like over here, navigation destination. We're going to be listening for category, and we will get the category. So what's going to happen over here is that when you provide a navigation link and you provided a category, whenever you click on the category view, it's going to look for a navigation destination which is of that particular type, which is category.self, meaning that particular type. If it finds the type, then it's going to give you the category, which is literally coming from here, and then you can provide any destination. So I'm going to use a text destination right now. So I'm just going to say category.name, so that at least you can see that we are going from one page to the other. And there we go. We can at least go from one page to the other successfully, right? So that's pretty cool. But what we really want to do is in the products screen, we want to display all the products. So for that, I will create another screen. Screens are kind of like the large thing, like every page is kind of like a screen, and views are much more smaller than screens. So I like to distribute it like that. And I'm going to call it category detail screen. All right. In the category detail screen, if you want to use that, you are going to pass in a category so that we know that which details are we talking about. This means that now we need to pass in some dummy category over here for it to work. So I can say whatever, clothes and all that stuff, URL. Again, I have to pass in some dummy category. You can create dummy categories in many different ways. But right now, I'm just going to paste stuff from there to here. Oh, I don't think it's actually allowing me to copy. Let me copy this so that the page can at least compile. All right. Now we can start using the category detail screen. Let's go to the category list screen. And instead of going to the text view, we will go to the category detail screen, passing in the category. Great. Now I can go to the category detail screen. Okay, but what should the category detail screen display? Well, the category detail screen should go and fetch all the products based on that category and then give us a result. That's the thing that should happen in the category detail screen. So this means that we need access to the environment object. I will go ahead and inject the environment object over here, store model with HTTP client. And this is only for the preview, or else the preview will not work. And then I will try to access the environment object, which is maintaining the state of the entire application in our case, because our application is quite simple. Okay, so what should we do over here? Let's put a small placeholder. Over here, we can say self. So the question is, what is better, SwiftUI or UIKit? I actually enjoy SwiftUI because it's just easier to create these interfaces. I mean, if you had to do the same thing in UIKit, you have to create a UI table view delegate, UI table view, all that stuff. in SwiftUI, it's just a list. Behind the scene, it's a collection view, UI collection view, but all of that is hidden to us. So I definitely enjoy SwiftUI much more. Okay, so now the question is, over here, we need to go ahead and get or load all the products. So I'm going to create a function. I'll call it load products. This will be an async function. But the product should be loaded based on the category. And that is a job of the store model. Load products by category. Or you can simply say load products, I mean, just to be simple, and just pass in the category ID. Right? Let's go ahead and create the resource. Resource will be resource. The URL will be APIs dot products by category. Products by category, this is just a URL where you can pass in a category ID and it will generate the URL for you. And then I can pass in that what am I looking for? I'm looking for an array of products. And then it's going to return me something, which is http client.load that particular resource. And I think this has to be async also. All right. Let's see. Oh, .url. That's the important part. I always forget that. There we go. That's it. But again, important thing to note over here is that I didn't go and create a new view model because I added a category detail screen. I simply use the store model, data store, whatever you want to call it, kind of like a global thing, and that gave me the data that I need. Now, the only thing I need to do is to call this load products, and I'm done. Let's go to the category detail screen. We'll say model.load products by the category ID, which is category.id, but we need to unwrap it or something. So get large ID, or just a little bit descriptive. We'll say category.id. Else, I don't know, you can throw an exception over here for, I guess. And then we can simply pass in the category ID. This is an async function, and this is also a try catch function. So we have to wrap all of this kind of like this. And let's see if it actually does something. Well, we need to update this part, right? Because right now it's just displaying a list with nothing. So let's go ahead and display all the products. And once we have the products, we can iterate through the product and then finally display the product name or something. Product dot, I don't know why it's showing it like that. Oh, sorry, it should be model.products, right? Model.products, because we are using the store model. And then it will be product.title. And there we go. You can actually see it. If I want to see the navigation stack or the navigation bar, I can also go ahead and add that. Navigation title can be category.name. And there we go. These are all the clothes. It's all random stuff, so you may not see all the clothes over here. It says rusted rubber chicken or something, which is obviously not clothes, but at least you can see some stuff over here. All right, so this is kind of like the architecture that I use when I'm building a client-server application. I don't like to add a new source of truth, which basically is a view model, if I don't want to or if I don't have to. And that's the important part over here. I just added one single observable object because my source of truth is the server, and that's it. And this store model is going to manage the entire state of my application. Granted that this application is not that huge, it's a simple, it's a medium or even like a very small size application, but even if you add like 10 function, 15 functions in there, it's okay. It's more of a deep class that you're building. It provides you a lot more functionality. Sometimes when you're creating more classes, it's actually more dangerous than creating one class that is doing related amount of work. So keep that in mind. All right. And the other thing, important thing, is that once we created these things, we were able to inject it into our views just by injecting it, as an environment object. And if I have another class, let's say catalog model, I can inject it over here also. Environment object, catalog model. That's perfectly fine. This is possible. You can do that. This means your application is kind of like growing, and now you need to shift. Store model is not doing the job, or store model is doing a lot of stuff. So you can move some part of it into catalog model so that it will be available to everyone. All right. Let's go back to our category detail screen, and let's kind of like take a look at it in action. If we start from the categories, we can click on clothes. Oh no, why it crashed over here? Okay, let me see over here. I think we don't have the, let's see, we don't have the navigation stuff. Oh, see that? We don't even have the navigation stack over here, so it's not going to work. So let's wrap everything in the navigation stack and put the environment object on the navigation stack. Let's go start again. Let's see if that works. Okay, so we can display all the categories. I don't know why it's working. Why is it failing? Any ideas, anyone? Unless I'm not sure why it is failing over here. Environment object. I think we did set the environment object. That is fine. We also did it over here. I think we did inject it correctly. I think you do have to do it like this. At least that's what I remember, but let me double check it. I'm going to look at some code. Are we setting the HTTP client? We are setting the HTTP client also. Looks like everything is fine. Let me run it in a simulator. Maybe that will give us a little better idea of what is happening over here. Probably I made the navigation destination in the wrong place, but doesn't look like it. Looks like it's okay. Okay, let me run it in a simulator. Maybe that will help. All right. Maybe we can kind of like look at the problem that we're facing, then why is it crashing? Because right now we don't have any clue. It didn't really give us any error. It just completely crashed. Any question, anyone? Meanwhile, I mean, while this is loading, any questions? So I find this architecture to be a little bit more simpler than anything else. And again, I use it only for client-server application. If I'm building a core data or Swift data application, I would use a variation of active record pattern. Okay, so it's working over here, you can see, but it was having issues on the simulator. So it's always a good idea to run it on over here. Will the Swift data and observation frameworks impact this architecture? No, I mean, it will not really impact this architecture at all. Yes, there will be some changes. I think you're instead of injecting environment object, I think you inject something different in a different way. But no, it's going to remain the same thing, exactly the same. All right. So that is it. I'm not sure why it's crashing on this. Looks fine. I wonder if it's something to do with this image or something, because we are forcefully unwrapping it. I don't, yeah, so there's a possibility that it's messing it up. I wonder if I can use a different image, but I don't think I have any image over here. Let's see if I can find something. Probably it's the image, or it can be something else, but that's only for this part. So I don't think it's going to be this part that is messing it up. We're not even displaying the image anyway. So, all right. All right. Any other questions, anyone? We can also add the async image over here if you want. We can go ahead and do the same exact thing that we were doing. I think it will be product dot images. Now this is a problem because images is an array, so you need to get the first one from there. The first one, if that fails, then you should probably get the actual image from somewhere else. All right, so you have to take care of those issues. All right, let me see how I was doing the images part over here. Products, product view. Over here, the product view is not going to do much for you because if I create a product view, it's really not going to do much. Images dot first. Okay. All right. Any other question, anyone? All right. So let's just talk about a little bit for the future, because in the future we will also look at how to add a new product. That's the important part, right? So in the future, we will do something like this. Save product. And we will have a product, which will be a product. Okay? It will be an async function, it will be a throwable function, and all that stuff. And then we will just save the product. We will use HTTP client to save the product. All right? This means that this particular store model is going to keep on kind of like growing and growing, but it will be accessible to all our views. If I want to sort something, right now if I go to my details screen and let's see if it displays, in my details screen I can see all of these products. If I want to sort something, if I want to sort the list of products, then I can use the same technique. I can just write the function over here and sort the products. Right over here. All right. And then I can go ahead and put sorted products right over here. Sorted products. And now they're sorted. You can see on the right hand side, they are actually sorted. Now, when we do these kind of things, we have to be careful over here, because keep in mind that the category detail screen is not the one that is a reusable view. This is what we call a container view. A container view is responsible for fetching the data through the help of a model or store model or HTTP client, and then passing it to some reusable views. In this particular instance, we currently don't have much reusable views going on anyways. I mean, yeah, we have a list and everything, but maybe this part can be changed into a product view, but there's not much going on in this part anyways, right? If this was like using an image and all that stuff, then I should have done that. So let me actually go ahead and simply grab it from somewhere. I don't know if it will work over here if I grab it from somewhere. Let me go ahead and see if I create a product view over here. Is it going to work or not? Product view, which is simply a view to display products. Okay, so that is what the product view looks like. We will import SwiftUI. It's very similar to the category view, right? You pass in a product and you simply display the information about the product. Now we can start using this. So let's go over here. Instead of the title and only title, which is kind of boring, let's go ahead and display the product. And, well, some of them doesn't really have an image, I guess. Let's go ahead and not use the sorted one. So I need to use the ones that does contain the image. And there we go. So we are able to display the products. All right. So all the stuff that you're doing, if you're sorting the products, and that sorting is only going to be happening in the category detail screen, and you know about that, then you just put it like over there, and that's fine. This is just the transformation logic that you're putting over there, or presentation logic. All right. If you think that the sorted you will be sorting from different views, you will be sorting products from different views, then probably this logic needs to move somewhere else. Probably you need to move it into store model or somewhere else. Probably store model. All right. But most of the time, there will be only one view that is sorting the products. I mean, if you have another view, then you have to think about, okay, where should I put this logic so that I can reuse it? But right now we only have one view. All right. So all the presentation logic, transformation logic, I usually put it just inside the view unless it is being used by it is being required and used by someone else. Then I will move it into store model. All right. But most of the time it's not. It's only one view that is using that stuff. So that's why. All right. And the good thing about this is if I add, eventually, when I save a product and I add to the products array, eventually I'll add it like this, dot append, a new product, then all the people, all the views who are displaying the products, maybe there are favorite products, maybe there are this product, all will re-render themselves and all will update. Obviously, the views that are on the screen are in the navigation stack, not like all the views in your entire application, just the views that actually need them, which is awesome because everything will remain in sync and you don't have to create flags for, hey, refresh this, hey, refresh that, hey, refresh this. It will become super messy. All right. So this is the kind of like the architecture that I use when I am building a client server application using SwiftUI. If I was using Swift data or core data, my architecture will be a little bit different. If I'm using nothing, like no client server, no nothing, just everything in memory, then it will be a little bit different. So I usually add the observable object only when the source of truth has changed. So over here, the source of truth for our small application is the server. So that is why I have not added 30 different view models or anything for that matter. But if I was using MVVM, I would have created something like this. Category list view model, category detail view model. And some people also like to create inner view model to represent every cell of the screen. Category view model. And I guess in this case, they can use this. Oh, in this case, they will use the products, right? So product view model. That's a lot of stuff. That's a lot of code for 2 screens. I mean, sometimes people used to do that. If you don't want to do that, that's fine. But some people do. Some people like to create, even if you're displaying a category, what are these? Products? Okay, so these are products. So they will create a view model for each product also. So this is for this, and this is for the entire screen, like this. All right. So I don't like to do that. I have done that in the past, but it was just taking so much time to maintain all of those different things. And I was also not able to truly use SwiftUI. So instead of doing that, what I'm doing now is just I create a source of truth, the store model or whatever, and I just use it directly. I don't really create anything else between. All right. So you can kind of, if you want to, I don't really like to think it that way, but you can think of store model as kind of like a global model, which global view model, it will maintain the entire state of your application. All right. Some people like to call it data store. So that is good for you. That's perfectly fine. Usually the name of this people like to create, like I think there are apps in for what is it called from Apple? This called a food truck app, right? Food truck app. This is from Apple. Check that one out. And they simply call it food truck model. That's what they call it. I think they also have a Fruta app, which is, I don't know about fruits or something, which is from Apple. And in that case, they're maintaining the state and they call it just model, I think. Then they also have app for Swift data, which is backyard birds. In that, they're not using this approach. So they will create different models for Swift data part. So they will have a model for bird, they will have model for backyard, they will have a model for category. I'm just making all this stuff up. They will have model for food or whatever. And so that's a little bit different because this is more of a Swift data application or a core data application. All right, and all of these top two can be, these are applications with a single source of truth. That's not the server, but it's still single source. All right. All right, any other questions before we wrap up? So this is kind of like the part one because we still haven't figured out how to do the save and how to do the delete, and we will cover that a little bit later. But hopefully this kind of architecture, even if you don't use it, will spark, interest, critical thinking. Maybe you will go and check it out in the future. Maybe you will try it out and compare that, oh, this one works better, this one doesn't work. So all of this, and that is the whole point of these live stream, is to simply spark critical thinking that, hey, let me try to use this and see how it works for my application. And then I'll have a taste of both. I can use this one, or this one. Okay, I like this one. All right. I have written some detailed articles on my views on Swift UI. Sorry, it's too bright. You can actually go and read these articles. These articles are actually kind of long articles. So this one is the article about building large-scale application, mostly client-server, in which I cover a lot of different things. It's a very long article. And I also published this article on Swift data, how I will organize my code for Swift data. So you can definitely check those things out. All right. But apart from that, any other questions that I can answer? Any comments, questions? So if you have any question, you can write down on the chat. So this is going to wrap up our session for today. Hope you have enjoyed it and hope it has given you at least something to think about. Maybe you are working on your indie app, maybe you are working on a project, and maybe you will think that, okay, let me use, and by the way, let me be very clear, this is not me who is coming up with these architectures. This is basically Apple's architecture. Like if you look at all these applications right over here, this is what Apple is doing. Actually, in one of my articles, I do have a screenshot. If I go over here, maybe I think you'll have the screenshot right here. See that? So this is from a session called Use Xcode for Server-Side Development. This is a WWDC video. And what you're looking at the screen right now, this is Apple's code. And I actually came across this code after I was already doing it this way because I was already following food truck application. So this is kind of like the application that they're doing. You can see that Apple created a food truck model. And this is not to say that we should be doing or should not be doing something that Apple is suggesting. I tried out many different architectures, but I stick with this one because this one works for my client server needs. So that's why I didn't really blindly follow because it is from Apple. All right, so just to be very, very, very clear, I did not blindly follow any architecture just because it is from Apple. It took me kind of like 3 years to reach that point. So you can see in this, they are kind of like using one particular model, observable object, to keep track of the entire state of their application. See that? That is there available on WWDC video. The name of the WWDC video right there. And you can watch that video. It's called Use Xcode for Server-Side Development. So this is a similar architecture that I was showing you. So we're watching, so it's the same thing. Will you post this video? I would like to watch it again. Yes, this video should be available hopefully instantly. YouTube should be recording, so it should be available. But I'll post it on my Twitter, and you can follow me on Twitter at Azam Sharp, so you'll get all the updates. All right. All right. Any other questions I can answer before we wrap up? Is it server-side UI development? This video is not server-side UI development. You mean server-driven pages? No, this is not server-driven UI. I do have a course on server-driven UI. I mean, if you go on my website and go to courses, you will find a course on server-driven UI if you are interested in that part. But this is, no, we didn't really study server-driven UI in this session. So these are all the courses that I offer. I mean, they are all on Udemy. So there is a course on server-driven UI, but that's not what we covered today. All right. All right. So I'm going to wrap it up. Thank you so much, everyone, for coming. Hope you have enjoyed it. And I will share all the stuff on on Twitter. I think it should be available already, hopefully. But once I end the stream, it should be available. So again, thank you so much for attending, and hopefully we can do it again in the future. So again, thank you so much for coming, and I will see you in the future. Thank you.